Hello, anthropology students, and welcome to week 13 of our course. This week, we're going to begin focusing in on Homo sapiens, and we'll be mostly focused on Homo sapiens for the rest of the semester. All right, so if you remember, I'm sure you remember, last week, my setup for last week was talking about Homo erectus had evolved in Africa, then spread into Asia and Europe. And then Homo erectus evolved into Homo heidelbergensis in Africa and Europe and Asia. And then heidelbergensis went through two evolutionary changes. Up in Europe, during an ice age, they evolved into Neanderthals. And Neanderthals were the focus of our class last week. This week, we're going to look at what happened to the heidelbergensis down in Africa. They evolved into Homo sapiens around 200,000 years ago. So that's where we are this week. I can also give you a quick reminder about scientific names because you're going to have to be writing scientific names in pretty much all of your answers for the third exam. So I want to give you a reminder about how to write them correctly. Basically, when in doubt, just copy how you see it written in my exam answers or in all of the readings, okay? You capitalize the genus, lowercase the species, italicize these Latin names. So I want you to do all the scientific names correctly, but be particularly careful about your own name, because if you make a mistake in writing your own name, I probably am going to mock you a little bit on your exam for not being able to spell or write your own name correctly. So that's just a heads up, right? Remember, Homo sapiens, there's always an S on the end. There's no such thing as a Homo sapien with no S. Singular, plural, they both have the S. So watch out for that. Okay, so you have also seen this weird looking hominin chart before. We talked about Homo erectus and the hobbits, and last week was heidelbergensis and Neanderthals. So this week, here we are talking about Homo sapiens. So Homo sapien skulls are a bit different than the skulls that we've been seeing so far. Okay, this picture here has a Neanderthal skull, but Neanderthals and heidelbergensis and erectus skulls were very similar in the overall sort of shape and structure. So this is a good comparison of Homo sapien skulls compared to these other hominin species. Homo sapiens have a very flat face. That means from a profile view, it does not stick out very far. So from the forehead down, it's relatively flat. We have a much smaller brow ridge than a lot of these other species, especially the earlier ones with very big brow ridges. Homo sapien brow ridges are small. We have, I think I've mentioned this before, a big old forehead that goes up, right? Other species like Neanderthals and Erectus had a swept back, sloped forehead. Our forehead goes up, and this is part of what gives us overall a very round skull, right? I think I've mentioned in various classes that, a Homo sapiens skull is shaped sort of like a soccer ball. And these other hominins are more football shaped, meaning American football, this sort of long and low skull. Homo sapiens skull bones are a bit thinner than the earlier species and Neanderthals. Neanderthals had very thick skull bones, heidelbergensis too. Sapiens are a little bit thinner. And there is this weird feature on Homo sapiens skulls. And that's if you look at the lower jaw, the mandible sticks out in a weird way that you don't see in any other species. All the other species don't have the lower jaw jutting out. Homo sapiens are the only ones with a chin. Why? There's not conclusive research showing what a chin is for and why we have it, but I'm happy to hear your thoughts on why in the world Homo sapiens have their bone juts out down here. You can post your ideas in the discussion board about that this week. Okay. But this is what we see, skulls that start to look like this more so than these other types of hominins. And so we get an overall head and face shape that changes here. So these may look like people you know. I don't know. Sometimes I've had it suggested before, maybe like this. But we get Homo sapien shaped skulls now. Okay, so I want to tell you about the fossil evidence for these skulls. So here's a chart of the fossils of modern Homo sapiens. And there's these two sites I'm going to start with. They're both in Africa. One is Omo Kabish and one is Herto. Okay, so I'm going to tell you a little bit about these two sites because they're very important. Okay, the first site, the older site, is Omo Kabish in Ethiopia. And they have some fossils here that are from 195,000 years ago. Okay, so that's good. The date is important. We're going to use that. But the problem with this site is that there are only fragments. Okay, they didn't find a complete skull. They just found broken pieces. Okay, and in this picture here that I'm showing you, the pieces that they found are represented in this sort of brown copper color. And the pieces they did not find are in this gray, lighter color. Okay. So as you can see, it's not a complete skull. They just found bits and pieces. They found fragments. Whenever anthropologists find fragments, that raises questions, right? And it sets up a debate. And the debate is whether these pieces are from a skull that belonged to Homo heidelbergensis that we talked about last week, or 2 weeks ago. We talked about heidelbergensis at the end of the erectus lecture. So was it heidelbergensis, or is this the new Homo sapiens species? So, every week there's lots of debates in paleoanthropology because that's what they do. But actually, most anthropologists are pretty sure these are Homo sapiens. And it's because of the pieces they found. Okay, so look at that picture closely, right? What did they find? They found some really key important features, okay? If you look here, they found this piece here, right? Which shows not particularly large brow ridges and the forehead that goes up. You can see it in this view here. So they found a skull with small brow ridges and a high forehead. And they found a lot of the back of the skull. And this also helps show the shape of the skull, right? That it doesn't look long and low. It looks to be a high round skull. And the other key feature they found is right here. They found a chin that sticks out. So those key features make most anthropologists say, I do not think that is heidelbergensis or erectus or Neanderthals or anybody else. This looks like bits and pieces of a Homo sapiens skull. So I'd say this is probably the earliest fossil evidence for Homo sapiens. It looks reasonably clear. This is probably Homo sapiens and not an earlier species. Okay, so that's the Omo site from 195,000 years ago. Now, the other site I wanted to mention is this one. It's Herto, also in Ethiopia, but the fossils here are a little bit younger. These are about 160,000 years old. Here, the fossils are in much better condition. They have 3 different skulls, and they're much more complete, and these look to be very clearly Homo sapiens. They've got the modern brain size. around 1,400 cubic centimeters, which is larger than Heidelbergensis and smaller than Neanderthals. It's got the high, round, modern brain shape. So this is good, solid evidence coming out of Africa for the origins of Homo sapiens, okay? So back to the chart, those are those first two sites, the fragments here at Omo Kabish and the good high quality skulls over here at Herto. And then they have more fossils too coming out of Africa and the Near East that are quite old, but a little bit later than those two sites. So when I give you the date for Homo sapiens, when I say they evolved around 200,000 years ago in Africa, the fossil evidence behind that date and location are these two sites, those fragments at Omo and the skulls at Herto, right? And what we can tell by this evidence is that we definitely have Homo sapiens at 160,000 years ago. And we probably have Homo sapiens at 195,000 years ago. So then the question is, when did they begin? And the idea is, it's unlikely that this fossil here, right, would be the very first Homo sapien ever on the planet who also happened to be fossilized and we also happen to find, right? That's not going to happen. So the basic idea is once you start finding Homo sapien fossils, that means they're around and they've probably been around for a little while. So you just kind of round back a little bit and say around 200,000 years ago is probably when Homo sapiens first evolved. So I just wanted you to be clear on the evidence I'm using to give you that date for 200,000 years ago. And Africa, of course, because both of these sites and a lot of the other early sites are all in Africa. All right. So at this point, what we have are what is often called in your readings anatomically modern Homo sapiens, meaning physically their bodies are fully modern, right? Their skeletons match modern human body proportions. Their brain size is the same as ours. The shape of the skull is the same as ours. All the body proportions are the same. So here we are, about 200,000 years ago in Africa, we have modern Homo sapiens, hominins that match us physically. All right, so hooray, there you go. There's Homo sapiens. Not my favorite species, but, they're kind of interesting sometimes, so they're worth talking about. So we're going to spend a few weeks talking about them now that we have them. So what I'm going to do today is I'm going to start by talking about some life history traits. And life history means sort of the timing of various stages and developmental patterns in an individual's life, okay? And we're going to look at both biological adaptations and some cultural adaptations and see how they connect to each other. Okay? So we're going to look at some problems in our evolutionary history, some solutions to those problems, and we're going to look at this all by looking at both physical changes and behavioral changes in our species that make us a bit different from the earlier hominins that we've been talking about. All right, so we're going to start off by talking about something we have been talking about for the past couple months, is brains and encephalization. Remember, encephalization is brain size. Okay, so let me give you a quick review. Like a month ago or so in class, we started talking about hominin evolution, right? So if we jump back in time to about 6 million years ago, this is when the first bipedal hominins evolved, right, on the plains of Africa. And for the next few million years, we have hominins with bipedal skeletons. You remember all the changes we talked about with like the foramen magnum and the curve in the spine and the legs and the angle and the feet and the toes. Do you guys remember how bipedalism changed the shape of the pelvis? We went from a long, flat pelvis to a curved, bowl-shaped pelvis. Okay. The pelvis is going to be relevant to what we're talking about here, okay? So I just wanted to remind you about the change in the bipedal pelvis, making it a short, wide, bowl-shaped pelvis. But back to encephalization. At first, there's no change in brain size here, right? All these early hominins, you remember Ardipithecus ramidus, Ardi, and Lucy and Salam, Australopithecus afarensis, and all the robust Australopithecines, they all had chimpanzee-sized brains, around 450 cubic centimeters. But then, around 2.5 million years ago, we started to see brain size increasing. Right? And the first species that had the brain size increased, do you guys remember who that was? Maybe Homo habilis at 2.5 million years ago. We saw encephalization. Brain size went up to 630 cubic centimeters. Habilis was the one that was using older one tools and scavenging and had the bigger thumbs. Then we saw brain size go up again with Homo erectus, right? That went up to about a 900 cubic centimeter brain. Homo erectus had a whole bunch of other changes, right? Tall, long, lean body, designed for running and persistence hunting, lost their fur, got dark skin, sweating, right? Remember? Awesome, sexy Homo erectus. Then we saw Homo heidelbergensis show up with an even bigger brain, around 1,250 cubic centimeters, making fancier tools, had upgraded that Acheulean hand axe into the Levallois tools. There was that weird sinkhole thing going on with heidelbergensis, Cima de los Huesos. And then now what we see is about 200,000 years ago, Homo sapiens show up, right? We evolve and our brain size is about 1,400 cubic centimeters. Okay, so this is the trend we've been seeing in brain size over the past couple million years. As brain size has been steadily increasing and increasing and increasing, right? And yes, Neanderthal brain sizes were massive, but they're off on a separate lineage. Okay, so now go back to thinking about the pelvis that changed about 6 million years ago. So if you look at the pelvises, right, here is the pelvis sort of looking down from above, right? Here's a chimpanzee up at the top, you know, quadruped with that long, narrow pelvis. And then here's Homo sapien pelvises, good old bipedal pelvises. So what we're focused on here is the pelvic opening, right? So what's important about the pelvic opening? I assume you guys can guess where I'm going here. And that is what will be passed through the pelvic opening, right? Male pelvic opening, nothing useful is being passed through there, so we can forget about that. But this pelvic opening, okay, this is where the baby comes through, right? As it passes from the mother's uterus down through the pelvis during birth. So this is what I want to think about, right? The opening of the pelvis compared to the size of the baby's head, which is related to the baby's brain size, okay? So let's take a look at chimpanzees here, okay? So this is a picture, again, looking at the pelvis, looking down at the pelvis from above. Here's the mom chimpanzee's pelvic bones, right? And on the left here, the black is her pelvic opening and the white is the baby's head. And this is just sort of in a little graph picture form, right? Is for a chimpanzee, her pelvic opening is represented by this gray oval and the baby's head is represented by the blue, okay? So what do we notice here, right? Basically plenty of room easy peasy, right? A chimpanzee mom, basically, she goes up into her nest at night. She just sneezes and the baby slides right out, right? Plenty of room, no problem, okay? And if you think about it, for birth, that's the whole point of biological evolution is reproduction, right? Birth should be very easy and straightforward, okay? And for chimps, it is. But now, what we want to think about is this idea of a conflicting selection pressure, right? That's our starting point. 6 or 7 million years ago with a hominin, our ape ancestors in the forests of Africa with bodies like chimpanzees. But then around 6 million years ago, our hominin ancestors got pushed out of the forest down onto the ground into the savannas. And this changed their bodies for all the advantages of being bipedal that we talked about a month ago, right? So hooray for being bipedal, and being able to walk and save energy out in the savannah. So that changed our bodies. And at first, that's fine, right? Because nothing had changed really about the brains. It just changed this to sort of more of a wide opening instead of a long opening, right? But then 2.5 million years ago, in response to things like intense climate change, we started seeing in the hominin lineage the advantages of getting a bigger brain, right? And it was better to have a larger brain so you could make tools and scavenge. Then it was an advantage to have an even bigger brain so you could make better tools and start hunting. And then an even bigger brain, and then cooking and fire and tools, right? So bigger and bigger and bigger brains until what happens, because every time the brain grows, the baby's head grows until Homo sapiens, right? You get this situation now where the newborn's baby's head has grown from about 140 centimeters brain size to about 340 centimeters in brain size. Ouch, right? Now, the size of that baby's head is larger than the size of the pelvic opening, right? So now we're going to have to talk about how you fit that big old baby head through here, okay? And one of the ideas that comes up at this point is, well, damn it, why didn't we just, evolve a bigger pelvic opening, right? To, expand, right? Why didn't the pelvis and the hips get wider? There seems to be two issues here at play. One has to do with bipedalism and the efficiency of bipedal walking. It seems like there's some research to suggest that changing the shape of the hips and making them wider, you would lose some of the energy efficiency in walking, okay? Wider hips are not the best for walking. And, for our ancestors who were nomadic foragers, walking was a way of life. There was too much selection pressure to keep the pelvis in a good, efficient bipedal shape. And we couldn't get wider hips because of those evolutionary pressures. And then there's also an issue that I'm going to talk about more as we discuss things is the energy involved in growing a baby inside of you. This is called gestational energetics, and the ability to, keep a baby in and how long you can keep it in. That also puts some interesting limitations on things. Okay, so I'm going to talk about that more. So we're stuck with this bipedal pelvis with this sized pelvic opening, but evolution wants us to have giant brains. So how do you fit a head that's larger than the opening through? So you guys know how that baby head gets fit through? There is a very interesting adaptation that Homo sapiens have that we don't see in other apes. Okay. So let's take a look at this baby head. What we see is this is a view of the baby's skull, looking down from the top. So this is the top of the baby's head. Here's the back, here's the front. And the whites are the bone plates in the head, right? Your skull is made up of different bone plates. And the black here is cartilage, okay? What we have in a Homo sapiens is this thing called a fontanelle, okay? It is a soft spot on a baby's head. Okay? If you feel your head, it's not there, right? Your head is solid at the top, okay? Okay, but have any of you felt the top of a newborn baby's head, right? It's a little squishy, right? There's a soft spot there. So what that is, it's because the bone plates are not fully fused together. That happens later during development, okay? So there's this piece of cartilage in the middle. So it feels really weird. If you have not felt it, I definitely recommend you go find yourself a newborn baby and feel the top of their head, you know? And it's okay, you can touch it, you're not gonna hurt it. It's really thick cartilage. You can gently sort of press it, you know, maybe if the mom's worried when she's not looking, reach over and touch the little baby's head. There's that soft spot there, okay? And it's interesting, okay? But what that soft spot is that's evolution, okay? That's an evolutionary adaptation that we have. Because what does that soft spot allow the skull to do? It allows flexibility, right? It lets those bone plates shift and move, okay, in a way that your skull cannot move, right? If the bone plates in your skull shift, you're in trouble. But in a newborn baby, they have flexible heads, right? Because the idea is that head needs to compress, you know, and squeeze to get through the pelvic opening that is smaller than the baby's head. Okay. So another question is, how many of you have seen newborn babies, right? What do they look like when they first come out? Especially their heads. Okay. And if you've seen a newborn baby, you know what I'm talking about. If you haven't, if you've only seen babies on TV, those are not newborn babies. What you'll often see is a kind of a deformed head. Okay, so I can show you a picture of what I'm talking about here. Okay, so here's a baby, right? Take a look at this baby, and particularly take a look at this baby's head. Okay, the shape of the skull, right? What's happened here is the baby's head, thanks to that fontanelle, thanks to the movable plates, has been crushed, okay? That's what contractions are, right? It's the mother's body crushing that baby to squeeze it out of the pelvis, okay? So, you know, that's why, you know, newborn babies, they look like they've just been through a fight, right? Their face is all puffy, they're all, you know, bloody and purple and stuff, because the mother's body just kicked their ass, right? And crushed that head to get it through. So it may look traumatic and scary when you first see it, okay? But that's evolution for you. That's an adaptation we have to get those giant heads to get through the pelvic opening. Okay, and I also want to mention, this is just a side tangent, but you know, pictures of newborn babies that you see posted on, you know, social media, you know, Facebook and Instagram and stuff like that. What are the in the hospital? You know, what are those newborn babies wearing? Right? Have you seen the pictures of the newborn babies in the cute little knit caps, right? And you know, the mom and maybe the dad are like, "Oh, here's our little baby," and they post it on social media. Why is that baby wearing a hat? Right? You're gonna hear, like, "Oh, it's because it's cold." No, it's not because the baby's cold. It's because the baby's ugly. and they throw a hat on it so that mom and dad is not traumatized and everybody can post their cute baby pictures, right? It's to hide that thing going on there with their head. So now you can just think about that next time you see your friends posting baby pictures of their ugly babies under those hats. Okay, so this gets crushed to squeeze through, but then what happens to it, right? Does it stay that way? How many of you still have freakishly weird looking heads that look like this? No, right? It doesn't stay that way. Again, thanks to evolution, right? Those flexible skull plates can then go back into shape, right? Sometimes as fast as just 24 hours later, there you go, the baby's head. This is the exact same baby. I am sure of it. I know very well this is the exact same baby. The head goes back to a normal shape. So that's what's going on there. So I just want to prep you for that idea because, you know, even if you're an anthropology professor and you see this crushed thing come out of somebody's pelvis, you're like, oh my God, what's going on? It's an alien. Be like, no, wait, this is evolution and fontanelles and adaptation, right? It helps you understand what's happening there. Okay, so now you've got your baby, right? Human babies are a problem, right? There's lots of issues here with babies, particularly human babies. So despite that biological adaptation of the fontanelle, giving the baby a soft head, okay, still human birth can be very difficult, right? Much more difficult than, again, like a chimpanzee. Like I mentioned, a chimp just goes up, pops a baby right out, no trouble. Human birth can be a much more laborious, prolonged, risky, difficult process, okay? Despite the help of a squishy baby head. So what's been the evolutionary solution to that, right? Homo sapiens have extremely difficult, potentially dangerous, and risky births. Compared to almost every other animal, animals don't tend to have trouble giving birth. Homo sapiens do. And we have been for our whole evolutionary history since we got those big brains. So what's the evolutionary solution to a woman going through a difficult birth? The solution here is very interesting. And that is, it brings in culture here. It's sort of a combination of biology and culture, is that biological birth is difficult. So it seems to be a cultural universal to have assistance during birth, right? Whereas a chimpanzee mom goes up in her nest alone, pops out the baby, comes down and say, hey, here's my baby. That's not how it works with humans, right? When somebody starts going into labor, everybody doesn't say, oh, well, go take a hike in the woods, have your baby, and then come back when it's all done. No. We have evolved biologically and culturally to offer help to women who are giving birth because it is expected to potentially be a difficult process, right? You know, it can take hours. You can be the woman can be relatively incapacitated during those hours going through labor. So somebody needs to be there to help out, right? So who can help out during this birth process? Right? Lots of people can help. Basically, anybody can help. There is cultural variation here in who is supposed to help during the birth process. In some culture, it's midwives, sort of women with experience in birth who are specialized in helping in the birthing process. It could be the mother's female relatives, her moms, aunts, sisters, could be just friends. It could be fathers, right? I'm sure in our evolutionary history, there's been a couple of useful fathers in there somewhere, right? Anybody can help, right? So the fact that humans have somebody around to help is sort of a biological evolutionary universal, but there's cultural variation in who is supposed to be there helping, right? And like I said, you may just need somebody there to give you emotional support and, remind you to breathe and say, you can do this, sort of be a cheerleader. Or you may need somebody to, you know, get you a drink of water. It's a long process. You may get thirsty. You may get hungry. You may want somebody, you've been here like in labor for 6 hours. You're like, damn it, I'm hungry. Make me a sandwich, And cross-culturally, the data shows it is pretty normal for women to be able to eat during labor. The fact that hospitals here in the United States will not give you food during labor, that's a whole nother issue. That's a cultural thing with, American United States culture. That's a myth. You can eat. So, you may need somebody to keep the predators away. Just there's lots of things going on in our evolutionary history. So it looks like we have always provided help to women giving birth. And, like I was saying, in our modern setting, it's in a hospital with like doctors and pediatricians and nurses, right? That's relatively new, okay? To have it take place in a hospital. It hasn't been like that for 200,000 years. And another thing I want to remind you guys of is probably one of the ideas that popped into your head within the past couple slides is the idea of C-sections, right? Cutting a woman open to take the baby out. How long do you think we've been successfully practicing C-sections? Right? Do you think we were doing that 100,000 years ago with a sharp rock? Not successfully. So we have been as a species, having successful birth for 200,000 years without things like epidurals and C-sections. Because birth can be difficult and simple things can happen, like with the baby's head, right? It has to be crushed to get through the pelvis. It can get stuck, right? Because not only does the baby's head have to get crushed, it has to do this complicated acrobatics to go around. So what happens if you're giving birth and your baby gets stuck? What are you going to do? Sort of reach in there and feel around? It's a really awkward position. You can't see very well. You may need somebody to look in and say, oh, I see. The baby's head just needs to turn a little bit or help guide the baby out, right? And that's another reason why somebody would be around. So again, as a species, we have been giving birth successfully for 200,000 years without modern inventions like C-sections. And I just want to throw in about C-sections. It is true that C-sections can be medically necessary and can save lives, okay? Sometimes they are needed, okay? And, sometimes they're great. But again, there's cultural variation in how often C-sections are offered and performed. So I would just be very suspicious and concerned about getting C-sections in sort of a sketchy place like San Diego, where there are unusually high rates of C-sections compared to the rest of the country and the world. Right? If you are offered a C-section here in San Diego, make sure it's for medically necessary reasons and not just because, the doctor prefers to schedule your birth so he can go play golf later in the afternoon, or the fact that a C-section is a medical procedure that a hospital will make much more money off of. So there's just other ideas going on there. So C-sections were not a thing until very recently. All right. So somebody's there to help a woman give birth, to help guide the baby out, or give her encouragement and take care of her during the birth. But then we give birth. Okay, so we give birth to a baby. What can a human baby do when it's born? Okay, we give birth to undercooked babies, and I use the term undercooked for that analogy that people sometimes have when a woman is pregnant. They'll say she has a bun in the oven. I don't know if people still say that, but I've heard that before, right? A bun in the oven. When that bun comes out, it's not done baking. It's all doughy and mossy and all kind of. The technical term for undercooked babies are that human infants are born highly altricial. Okay, they are extremely helpless at birth, right? And this again ties into encephalization. It all has to do with brain size. Okay. Because of the fact of trying to grow our big, enormous brains, after being in the womb for 9 months, our nervous system is not finished yet, okay? Our brain and nervous system are not finished developing. That's what I mean by altricial and undercooked. And when I asked you a minute ago, what can newborn babies do, right? They can make a lot of noise. They can ooze all sorts of unpleasant substances and sounds out of every orifice in their body, right? But if you think about it, right? Have you ever seen those nature videos of, a gazelle or a zebra giving birth on the savannas? The baby drops out, and how long is it before that baby zebra is up and running? Right? Like a few minutes. Okay? How long is it before a human baby is up and running and can run alongside their mom? Years. Okay. Even a chimpanzee baby, when they come out, right? They pop out and they can hold on to mom, and grab on their fur and hang on there while she goes on about her business, climbing through the trees, right? But human babies, other than a sort of a weak little grasping instinct, they can't support their own body weight. They can't sit up. They can't crawl. They can't walk. They can't talk. And newborn babies, sometimes there's some training that has to go in before they're good at nursing and sleeping. How good are newborn babies at sleeping through the night for 8 hours? If you've been the parent of a newborn baby, or you know anybody who's a parent of a newborn baby, they tend to be exhausted because babies don't sleep through the night. Okay. And, if you're the parent of a newborn baby at 3 a.m, looking at your precious little baby, who's wide awake, and you're like, it's nighttime. Why can't you sleep, right? What kind of animal doesn't know how to sleep? Human babies. That's the animal that doesn't know how to sleep, because their brains are so underdeveloped that they don't even have proper circadian rhythms yet, right? Nothing's working in their bodies. So that's why they can't do anything, okay? They can't even sleep properly. It takes a while for them to develop that, okay? So chimpanzee babies are born much farther advanced than we are. Human babies are way behind, okay? It takes months to start to catch up. So you could think of the first 3 months of the baby's life as sort of the 4th trimester, right? If you're familiar with pregnancies, they talk about it in terms of trimester, first, second, third trimester, and then the baby's born. If, in a certain way, evolutionary speaking, human pregnancies only last 9 months, the same as the chimpanzees. Chimps and humans give birth at 9 months. Human babies should probably stay in there for another 3 months and finish cooking, right? And finish developing. Then they'd be born much closer to chimpanzee level of development. Okay? But think about that. You give birth to a baby after 9 months, right? And the difficulty of squeezing that baby through your pelvis when it's been in there for 9 months Imagine if you tried to keep it in another 3. How fast babies grow. You can't do it, right? Human pregnancy cannot last another 12 months, okay? At 3 months old, the baby's brain is 560 centimeters cubed instead of 340. It barely fit through the pelvis at 340. At 560, that baby's not coming out, okay? And this is also where gestational energetics come into play, like I mentioned in a previous slide. The energy of growing a baby inside you, right, is what you want to think about is one way to think about it is thinking about that baby as sort of an alien parasite growing inside the woman's body, okay? It's only got half of her DNA. It's not even fully her, right? It's this other little organism that is trying to take as much energy from her body as possible to grow, right? The baby wants to grow. It needs food. The mother's body wants that baby to grow, but she wants to keep some of that energy for herself, right? She wants to give it just enough to keep it healthy and happy and growing, but save energy for her. Each day that baby grows, that baby gets stronger and more powerful and sucks more energy from the body, okay? From the mom's body. So at about 9 months, given the size and energy demands of that baby, the mother's body basically says, I am done. You know, if I keep that baby in any longer, it'll kill me. And it starts shutting down and delivers an eviction notice to that kid, right? The placenta starts to shut down, you know, the water breaks, everything in the body is saying, get out now, get out now. I cannot keep you in any longer. So, so get that little vampire out of you before it sucks all of your energy away and kills you. The beauty of birth. So that's what's going on here, right? Human babies are born sort of early, right, at 9 months. The same amount of time it takes for a chimp, but our babies are not that developed. So we give birth at 9 months, even though the baby's not really ready to be born. And they're super altricial, very needy at that stage, and are way behind the development of other ape babies. Okay, does that make sense? Some problems, that come up when you're trying to grow a big brain, and these are some of the solutions, right? Squishy baby head is an adaptation. Helping out during childbirth is an adaptation. Giving birth to a little early to really extremely needy babies, that's an adaptation. All right. So now, if we look at, so we've got this issue of altricial babies, right? Really super needy babies. Some problems and solutions here. And again, we've got biology and culture combining together. Taking care of the baby once it's out. What mammals do is nurse their babies, right? They provide milk. That's the definition of mammal. So all mammal mothers nurse their babies. And how long they nurse determines how often they have babies, okay? I believe I talked about this like a couple of months ago, back when I was talking about primate behavior. I talked about this idea of lactational amenorrhea. I think it was during the conversation about infanticide that we see in some primates when new males come in and take over the group, is that being pregnant takes a ton of energy, right? To support that little energy vampire parasite alien thing inside you. That takes a lot of energy from the mom's body. Nursing, feeding the baby with your body also takes energy. And basically your body doesn't want to do both of those things at the same time, okay? Because it would kill you. So while a female mammal is nursing, her body releases hormones to prevent her from ovulating, okay? So the longer you nurse, during that time you're not ovulating, so it spreads out the timing between having babies. So that's what I mean here. How long you nurse determines the IBI, which is interbirth interval, the spacing between babies. Okay, so right. So what I want to show you now is a comparison of apes and how this works with apes. Okay. If you look at some of these life history variables for female great apes, okay, that would be orangutans, gorillas, chimps, bonobos, and humans. Okay. We can do some interesting comparisons. And for all of these apes, the data is coming from wild, free-living primates, okay? And that includes the humans. What we're looking at in the human data is human foragers, hunter-gatherers, because we're trying to get away from modern technology and modern medicine and modern contraception, right? These would be what's called natural fertility populations, humans who don't use, any sort of artificial contraception and things like that. And that makes it much more comparable to the other apes. Okay, so I want to look at a few things here and think about how they affect the reproductive success of these individuals and species, right? Because remember, reproductive success, it's all about who has the most babies, right? And having the most babies is better. Having more babies is better is the idea. So if you look at age at first reproduction, this is at what age do females of that species tend to have their first baby? So what stands out here, right? Who has their baby first, right? Starts having babies first. And you can think of this as a race, right? If you look at gorillas, gorillas pop out their first baby at around age 10. So they're first out of the gate and often running towards reproductive success. Woohoo! Chimpanzees and bonobos, they start having their first baby around like age 13 or 14 years old. Orangutans around 15. Humans in hunter-gatherer foraging populations tend to have their first baby at around 19 or 20 years old. So if this is a race, humans are now in last place. We're starting much later than the other apes. Okay. Then we can look at how long, once the baby's out, how long they tend to nurse their babies. Okay. And this gives us the age at weaning, right? What age is the kid when it weans, when it stops nursing? Okay. And here are some interesting patterns pop out. Here, what may stand out here are orangutans. Orangutans nurse longer than any other ape. They nurse their babies for 7 years. Gorillas, chimps, and bonobos nurse their babies for about 4 years. The human average for nursing in these populations looks to be about 3 years, okay? That's worth mentioning here, again, because for people from the United States, Americans, when we think about how long do American women nurse their babies, how many American women nurse their babies for 3 years? It's very, very few, okay? But that's, again, a weird cultural practice of Americans, okay? In the United States, I think it's only 15 no, how is it? Yeah, only 15% of babies are nursed beyond, I think, 6 months. So in the United States, women tend to nurse for only a few months, and then that's it, okay? And so Americans think, oh, you only nurse your baby for a little while. No, it is normal for humans to nurse their babies for probably around 3 years on average. Americans are a weird outlier here, as we do not nurse our babies a normal amount. But that's just because America is weird. So why don't American moms nurse their babies for 3 years? Why do they stop nursing so early? Basically, there is a lot of things about our culture and our society that is anti-nursing, right? Women are discouraged from nursing in numerous ways. They have to stop nursing because they got to go back to work, right? They can't afford to stay home with unpaid leave or get fired from their job to keep nursing for years. Most jobs won't let you bring your baby with you to work and nurse while you're at work, right? And that has to do with, United States being one of the only developed countries on the planet that does not guarantee federally guaranteed maternity leave, right? We don't have laws protecting women like that in this country, right? There is no federally guaranteed maternity leave. It varies by state, it varies by job, it varies by country. Some jobs don't offer it at all. Some might give you, a few weeks of unpaid leave. It's just a mess in this country. Women have to go back to work. They have to go to school. If they bring their baby out with them and try to nurse while they're at the grocery store or shopping, there's a lot of social stigma against that. They get looked at and, people stared at and sometimes yelled at or commented on, like, oh, that's gross. Nurse your baby at home, right? Because Americans have issues with boobs and they're just, people in the United States are just full of issues. So just everything about American culture tries to tell women to stop nursing. So that's a bit of a tangent, but that's just to point out why this number may look a little odd to some of you if you don't think it seems normal to nurse your baby for 3 years. As a species, that does seem to be the norm for us. Okay, so back to what I was talking about. That 3 years, it fits in much better with all the rest of the apes. Another way you can tell what the norm for ape nursing should be is you can do this calculation based off of the mother's body weights and size and the baby's body weight and size and how fast they grow and the energy needs. And you can do a calculation that predicts how long the baby should nurse. And for gorillas and chimps and bonobos, it all matches up really well. And for humans, that calculation points to about 3 years, which matches the cross-cultural data really well too. So there you go. But I wanted to bring up the age at weaning, not just to bash American culture for being freaky, but to say this has a big impact on your interbirth interval. How long you nurse determines when you have your next baby, okay? So the interbirth interval, the spacing between babies, is directly related to age at weaning. So what we see is orangutans give birth about every 8 years because they nurse for 7 years. So orangutans get kind of a late start and then have a long spacing between babies. So they're kind of in dead last in producing babies out of the apes. Gorillas pop out a baby every 4 years. Chimps and bonobos about every 5 years. And look at humans. Because they cut down their nursing time to about 3 years, they can have a baby about every 4 years, right? So they can start to catch up here and start pumping out babies even faster. And if you shorten your nursing to just a few months, you can have a baby a year later, right? So shortening the nursing time can really change how quickly you reproduce, right? And how fast you can have babies. But humans, compared to the other apes, even with a 3-year nursing time, have the shortest interbirth interval compared to all the other apes. So that may be one of the factors that leads to our rapid population growth compared to a lot of the other apes. Okay, so back to the slide that I was talking about here. Now I've given you the data and talked about Homo sapiens, right? We nurse as a species for about 3 years and then naturally have a baby about every 3 to 4 years. Okay, so this is the time of nursing and then weaning. Now, typically for mammals, once they're weaned, once they stop nursing, they have to then start feeding themselves, okay? 24/7, right? They got to get all their own food for themselves every single day. Now think about Homo sapiens. If you nurse for 3 years, at 3 years old, Is your kid ready to feed itself all day, every day, 7 days a week, 365 days a year? A chimpanzee baby is. As soon as it's weaned, it feeds itself for the rest of its life from that point on. You know, but no, if you shorten this up and wean your baby at 2 years or 1 year or 6 months, is your baby ready to feed itself? No. So here's another way that humans are strange, right? This whole lecture today is about all the ways that humans are odd. Humans do this weird thing where we keep feeding our children after weaning, right? We're not nursing them anymore, but we keep giving them food, okay? So what this does is it creates this period of life that's called a childhood, okay? And it could be argued that we're one of the only species that really has a childhood, a period of life where you are not responsible for feeding yourself, okay? And it can be a very extended period, right? How long do parents keep feeding their kids? It can go on for decades, okay? So this is a weird thing in human evolution, right? In our species. So we want to ask why? Why would we do that? Why would we keep feeding our kids after weaning, even though no other ape does? What could be the benefits of that? And what I want you to think about is, what did you do during your childhood with all that free time that you were not searching for your own food and feeding yourself every day? What did you do during your childhood? What this does is it frees up that period of your life to grow and learn everything it takes to be a successful adult, okay? You learn language, you learn social skills. I think most of you went to school during your childhood, right? You learn everything you need. You learn all these life skills, okay? Because, at 5 years old, a chimpanzee may be ready to go with the rest of its life, but a 5-year-old Homo sapien is not. It takes much, much longer to learn everything you need to learn to be a successful Homo sapien. So that's what a child is for, right? That's the benefits. It allows you more time to learn. Okay? But again, this is really unusual. Most animals do not do this. Why? What is the downside of an extended childhood? What's the cost? And who's bearing the costs of extended childhoods? Yeah. What it is this is a very expensive time, right? And I'm not just talking money like we think about in terms of today, but energetically, calorically expensive, okay? The parent, right, the caretaker, has to provide about 12 million calories to that kid to raise it from an infant to the point where it's feeding itself fully every day, okay? So it takes decades of time and investment and energy and calories and food to raise up that kid, right? And the expenses, it's the adults putting in the time and effort to do that. And another thing I want you to think about is, what age do you think this is, independence, right? At what age is a human kid, and think about not in American culture, think about in a foraging society, in hunter-gatherer society, how we were for hundreds of thousands of years. At what age do you think a kid is fully independent, where they are every day they can bring in more food than they eat, right? Because if you're not bringing in enough food, if you're not bringing in as much as you eat, then you're relying on others. So at what age do you think kids transition from relying on others for their food to being able to regularly every day bring in more food than they consume? it might surprise you, or it might not, is that in most foraging societies, that transition happens at around 18 years old. Okay. Because think about this, right? If you're a hunter-gatherer, right, hunting, at what age are you able to be a fully efficient, sufficient hunter and go out and hunt, make your weapons, go out, bring down large animals, bring them back to camp? You know, you got to be pretty old to be able to handle doing that on your own. And even foraging, right? You guys might think, oh, foraging, that's just going out and collecting some berries. That's easier. No. Think about how much you have to learn to be a successful forager. How many hundreds of plants in your environment you need to learn to identify correctly to know which berries are toxic, which berries are edible. Learn the seasonality of plants, when they have food, which parts of the plant you can eat when. Some of those foods then require processing, how you have to break them or crack them or shell them or cook them or mix them with other things to make them edible. That's really complicated. So, if you've ever wondered why sort of in our culture we have this sort of magical at 18, you're an adult, it may seem kind of arbitrary. But if you look across at, hunter-gatherer foraging cultures, societies, that's about when you become nutritionally independent and you're a sort of a fully functioning adult that can bring in your own food every single day, 7 days a week. Okay, so I just want to mention that. Okay, so all of this childhood with kids that you have to feed, this is a biological problem, okay? This raises the problem of taking care of very costly babies and children, okay? And again, compare it to a chimp mom. A chimp mom easily gives birth to her baby. Her baby just hangs on to her. And she goes on about her day. She nurses it for about 4 years. And then after that, it feeds itself and she doesn't have to feed it anymore. Okay. She doesn't need help with a baby. Okay. But the weird thing is with Homo sapiens, okay, in the context of our evolution, which was hunter-gatherer foragers, okay, the amount of calories and energy required to raise a baby from infancy to independence, those 12 million calories, for a foraging mom, she has to get all of her own calorie needs every day, plus another 12 million for her baby. And then remember, 4 years later, she has another baby, so baby number 2. So now she's got a nursing infant and a 4-year-old who still needs to be cared for. Then 4 years later, she has a newborn nursing infant, a 4-year-old, and an 8-year-old who still needs to be fed and taken care of. Then 4 years later, she's got an infant, a 4-year-old, an 8-year-old, a 12-year-old, right? You just keep stacking on these caloric needs, okay? And it looks like biologically, we have evolved to produce babies that exceed what any reasonable foraging mother can provide, right? So how is that possible, right? How have we evolved to solve these problems of super expensive children, who take forever to grow their giant brains? What's the solution? That's the articles for this week. Okay, that gives you the solution. So what I want you to do now is please pause my lecture, stop listening to me, go watch the student presentation. I know you've already read the articles, so go watch their presentation, see what they have to say, participate in the discussion, learn what you need to learn about the articles, and then come back here and I'll continue on where they left off. So bye. Go watch the article presentation. Talk to you in a little bit. Okay, welcome back to my slides. Hopefully you enjoyed the student presentation and participated in the discussion over there. So I'll pick up where they left off and sort of highlight a few things from the articles I wanted to mention. So we will go back. This is a slide I was showing you before the articles, setting up this problem of how do we deal with taking care of very costly babies and children, how we evolved to solve these problems through allo mothers and cooperative breeding, right? That's been the solution, okay? Cooperative breeding. So let's look at who provides help and under what circumstances. So the first article was the Life on the Serengeti article that was about menopause. So what's going on there is the main idea of this article, sort of the main argument, is that with Homo sapiens, our post-reproductive longevity is an adaptive change, okay? So how they set this up is, first, you compare us to other apes, okay? And I think I've mentioned this before in some lectures, is that typical ape lifespan is in the 40s, okay? This applies to our living ape cousins and all the other earlier hominins. So orangutans, gorillas, chimps, and bonobos, their lifespan is into their 40s, and then they start to die. And the earlier hominins also would, their lifespan was in their 40s. This is Artie and Lucy and Homo habilis and Homo erectus and Homo heidelbergensis. They all lived into their 40s. Neanderthals were a slight exception to that in that they usually died in their early 30s, but that's because their lives were so hard. Okay, so that's standard ape lifespan. And most female apes are still reproductively active at the time of their death, meaning they're still having babies right up until when they die. Okay. Homo sapiens, us, we're weird. Again, this whole lecture is about how weird we are. Homo sapiens have an unusually long lifespan for an ape, okay? And this, I want you to understand what I'm talking about here. I'm talking about Homo sapiens in hunter-gatherer societies, Homo sapiens 100,000 years ago. Our species, even early members of our species, were living into their 70s and longer. Our biological lifespan is, twice, maybe not twice as long as, but, much longer than normal apes. And this, students sometimes have trouble. This doesn't quite register with them because you have this idea. You've been told that, oh, we used to die much earlier, much younger, and it's only thanks to modern medicine now and our modern, technologies that we're living into, old age. Right? Okay, so that story that you were told when you grew up is partially correct, but it's looking at a limited time span. It's true that a few hundred years ago, we tended to die early, right? Thanks to disease and birth complications and all sorts of stuff, right? Poor sanitation, right? So over the past few hundred years, humans used to only had short lifespans, and true, recently, we've brought it back up now into the 70s, right? But prior to that, you go back thousands of years, like 20,000, 50,000, 100,000 years, we were living into our 70s, okay? So we used to live, we used to be normal apes living into our 40s. Then we evolved into Homo sapiens and started living into our 70s. Then we took a downturn, right? Thanks to, we're going to talk about this at the end of the semester, agriculture and living in cities, packed, dense, disease-ridden cities. Our lifespan tanked and dropped back down, and we've recently started clawing our way back up to our natural life expectancy. Okay, so I just wanted to get that through to you that Homo sapiens naturally live into their 70s and beyond without modern medicine. That's our biological lifespan. Okay, so that's interesting that compared to other apes, we live unusually long. And also, what's weird is that we don't, or women don't keep making babies, okay, throughout their longer lifespan. They stop reproducing by around the age 50 or so, okay? This is menopause. And that's weird, right? Because if you think about it, right, the whole point of biology and evolution is reproductive success, to have babies. So if you manage to find a way to tack on an extra 30 years to this ape's lifespan, why not keep making babies for an extra 30 years, right? Think about how many more babies you could have. That should be the most reproductively successful thing to do. But Homo sapiens don't look like they do that, right? So this is you saw this in the article, the chart that was in there. This is looking at like how many individuals are alive at any given age for different apes. Okay, so you know, how many are alive in the population? So obviously it starts out very high when everybody's a baby, and then each year, or each age category, the number of individuals alive starts dropping off. So for chimps, all the apes, or the early hominins, things start dropping off, and by the time you hit the late 40s, there's almost nobody left alive. Okay. But if you look at Homo sapiens, what you see is after the 40s, there's still individuals alive, even though they're post-reproductive. They're not having babies anymore. So this is why, looking at the data on Homo sapiens, you're like, oh, that purple area, that's weird. That's different in Homo sapiens. Why? How did evolution produce that purple area? Okay. So back to my little summary. So why? Why did early Homo sapiens evolve to be so different? Why were we 100,000 years ago? Why were we living into our 70s, but not having babies? Okay. And this is where we get the idea of what's called the grandmother hypothesis. Okay. So what this suggests is that older women actually benefit from stopping their own reproduction, is that it would not be good to continue having babies into your 70s. Okay. Because think about that. What happens, think about pregnancy, right? And birth, being pregnant and giving birth. If any of you have experienced that, you know how hard it is on your body, right? And we've talked about in this lecture, the difficulties, the energetic costs of pregnancy and births, okay? Having a baby, if you're a Homo sapien, having a baby in your 20s, when you're in your prime, is still hard to do. What if you have a baby when you're 70, right? The problem there is the biological problem is as a woman gets older, the risks to her health and the baby's health increase, right? Think about trying to squeeze a giant baby head through your pelvis when you're 20. Think about trying to crush and squeeze that giant baby head through your pelvis when you're 70. Your pelvis will shatter and turn to dust, right? The toll it takes on your body just gets riskier and riskier each year, okay? And you see that in, it's risky for mom and the kid, right? Because you're giving birth to a baby that needs support. So you see this with chimpanzees and other apes is usually, when the mom dies in her 70s, she's still reproductively active. If she has a young baby, her baby dies with her when she dies. So it's dangerous for mom and the baby, okay? So the article talks about, if you invest only in your reproduction, if there's an animal that only cares about reproduction, it's likely to have low survival, right? Because it's not focused on other things about keeping itself alive. But for an animal, if you invest only in your own survival, you might not have high reproduction. So sort of in biology, there should be this trade-off. You need to balance both investments. Put some of your energy towards your own survival and some of your energy towards your reproduction. And the point here is that that balance shifts at different ages, right? At age 20, you can pump a fair amount of your energy into your reproduction and still survive. But at age 70, you got to shift to putting more of your energy and effort into your own survival and less into reproduction. So because of that balance, what evolution has done for us is create this situation where instead of creating their own babies, older women can invest in their grandchildren, okay? Because their grandchildren still share some of their genes, right? Their kids, their children's are their own genetic lineage. And investing in taking care of your grandchildren usually won't kill you, right? They just want cookies every now and then. Trying to have your own baby in your 60s or 70s could kill you. So it's a safer way to increase your reproductive success, is safely shut down your reproductive system. That's what menopause does. It shuts down your ovaries, makes it so you can't get pregnant. Then you have the time and the energy to put that into helping feed and care for your grandkids. And that's where you get the evolutionary benefits of both a long life and increased reproductive success. Does that make sense? Hopefully. Safely investing in your grandkids. Okay, so now I have a question for you, okay? So this is a little off of what the article is talking about. It's kind of a tangent, but it's one I want to see if we can pull off in the discussion board, is which parent is most likely to invest, okay? And this is the idea of you have 4 grandparents, right? Your dad's parents and your mom's parents, right? You have your mom's mom, your mom's dad, your dad's mom, your dad's dad. Out of all those 4 grandparents, I want you to think back to your childhood, right? Which of those 4 grandparents invested the most in you? You know, whether it was cookies or babysitting or money or childcare or whatever. Which of those 4 invested the most in you? And now I want to think about why. Why do you think that one invested the most in you? I usually have this conversation in the classroom and it works pretty well. We'll see if it works in the discussion board, but I just want to get some ideas from you guys about that, because there's an interesting explanation for why it almost always tends to be grandmothers. We'll see if it comes up that way, but most of you, if you answer this question, probably most of you, I'm predicting, are going to tell me one of the grandmothers invested more than the grandfathers did, and so I want to talk about why that is. Okay, so it's usually grandmothers, but maybe you'll prove me wrong in the discussion board this week. And then the article itself, this menopause article, does talk about which grandmother invests in which grandchild, that kind of thing. So they have this little section in here about paternal grandmothers versus maternal grandmothers and who does better with granddaughters or grandsons. It's a little complicated, but the idea here is it goes back to our genetics week from the beginning of the semester. You remember I told you about meiosis, the formation of eggs and sperm. I hope you remember meiosis. You might. That was a long time ago, though. But during meiosis, this thing that happens called crossing over and recombination, where genes jump around between different chromosomes, and that shuffles things up and creates variation. That was important in the beginning of the semester about meiosis. It comes up again here in this idea with your sex cells, your X and Y chromosomes, right? That determines whether you're male or female. So if you look at a chart like this, this is paternal grandfather, paternal grandmother, maternal grandfather, maternal grandmother. When you're talking about a male, they have an X and a Y chromosome, okay? When that gets passed down to a son, he gets the X and the Y, right? He gets an X from mom and a Y from dad. These chromosomes are not quite the same, so they don't do any gene swapping. The X does not swap crossover genes with the Y, okay? So what I want you to see in this scenario, the X chromosome from the paternal grandmother passes down to her boy, complete and whole, and then he passes that X on to his daughter, complete and whole. So this blue X gets passed down complete. If you look at this situation over here with the maternal grandmother, she starts off with two X's. So meiosis, she contributes an X and the dad contributes an X. When those are being formed, they do this swapping thing, the crossing over, and genes get switched around between them. So this X chromosome from grandma ends up with a few of, her husband's or the dad's genes on them. And then that gets passed on down here to the grandkids. So it is not fully grandma's X chromosome because it has some guy's genes on there, right? So all this basically means is that because if the granddaughter is a girl, she is slightly more related to her dad's mom because it's fully her X chromosome, right? And she's slightly less related to the mom's mom, whereas the maternal grandmother, she's equally related to both. So this is just a slightly complicated system to say, oh, that's interesting. I wonder if that genetic relatedness shows any patterns. And it turns out in a big, huge cross-cultural studies is that, what was it? Boys who were raised by, let's see, who was it? 31% related to the granddaughter. Boys who were related by their maternal grandmother did better, and girls who were raised by their paternal grandmother did better because it's the idea is, their paternal grandmother's a little bit nicer to them than they would be to their grandson. So I don't know if that's worth spending too much time on, but it was just an interesting thing how this simple little biological chromosome shuffling dealing with meiosis from the beginning of the semester comes out in cross-cultural patterns of, who does better under which grandparents, grandchildren, grandsons or granddaughters. So maybe interesting, maybe not, but I just wanted to add that in. Okay. But the main point of that article was menopause is an adaptive change, right? That's the main point of that article that I wanted you guys to get out of that. Okay, so now going to the other article, the Sarah Hurdy article, The Mothers and Others. She brought up this issue of, okay, so the problem with humans is we have an inner birth interval of 4 years, but at 4 years old, kids are not self-sufficient. So we have multiple overlapping altricial children. And the biological question is, how could evolution by natural selection produce babies that are too costly, too expensive, too difficult for Homo sapien mothers to raise on their own? Because like a chimp mom has no problem raising her babies on her own. Homo sapien moms need to provide 12 million calories. How is that possible? The evolutionary biological solution is cooperative breeding and allo mothers, right? So the idea here is we evolved to raise babies with a lot of help, okay? We are not chimpanzees, right? Chimpanzee females can raise babies on their own. So if you ever hear anybody talking about, women should be able to raise babies on their own, they better be talking about chimpanzees, because if they're talking about Homo sapiens, they don't know what they're talking about. Who can help raise babies? The article gives you lots of examples there, right? Grandmothers, who've gone through menopause can help raise babies. Other female relatives, sisters and moms and older siblings, friends, anybody, right? she gives examples of the Efe and the Aka tribes and how much other people hold the babies and carry the babies around. And then not just women, right? But men can help. Again, I'm sure in our evolutionary history, there have been a few useful fathers. The father can be useful. And she gives a really interesting example of even extra fathers, right? There's that partible paternity example, where when a woman, when she wants to have a baby, she'll sleep with multiple different men, because the belief here is that whoever has sex with the woman has contributed something, some genetic material to building that baby. So if she sleeps with 6 different guys, they're all the dad. They're all responsible for helping support and raise that baby. Okay. And I think this ties into something I talked about early in the semester. I think I asked you guys during one of the primate weeks about, do monkeys know who the father is, and do any primates even know that sex makes babies? And my point during that discussion we had in the discussion post was, no, nobody knows that sex makes babies. And this is an example of it, is Homo sapiens don't even necessarily know how sex works, that it's just one woman and just one man, because cross-culturally, there have been groups who had different ideas about how babies were conceived. So that's an interesting example of lining up extra fathers to help out. So the point here with all these examples that Hurdy's bringing up is that, evolutionary speaking, it is a biological necessity that we help cooperate to raise babies, but it's culturally variable who is supposed to help, right? It varies culture to culture, right? So it doesn't matter as much who's helping as long as somebody is helping, right? Okay. And then she gives you some ideas, some information on how this works. If you've taken like child development classes, you probably are familiar with this stuff, right? Babies do their part by evaluating caregivers and encouraging caregiving, right? They're good at looking at people, and they seem to be sort of scoping them out. And they encourage caregiving by being cute, right? If babies were not cute, we would not put up with them at all because they're so ridiculously expensive. But they're, manipulative little creatures that are trying to encourage you to bond with them and take care of them. And I'm sure you guys have heard, the old trope, the stereotype that, women around babies get like baby fever and it changes them, and they get all like maternal and whatnot if they're around babies. Interestingly, this happens to men too. She goes over some research showing how exposure to babies, like living with somebody with a young baby in the house, will change the hormone levels in women and men, right? Being around a young baby drops the testosterone levels of men. And, this makes sense if you think about it, right? What do you think of a guy who's high on testosterone? What is he interested in? Sex and fighting. That's not really conducive to caretaking. So lower testosterone levels might let the caretaking behaviors come out. And she mentions, she mentions this really interesting, disturbing phenomenon that we see with cooperative breeders, okay, is maternal investment. How much time and energy the mom puts into the baby tends to increase when there are other helpers around. And she talks about other species of cooperative breeders. So if a mom has helpers, she puts more effort and energy into raising her kid. But if she does not have helpers around, it will decrease, right? The maternal investment, you see it decrease. So what happens is cooperative breeding species, right, have the highest rates of maternal abandonment, of moms abandoning their baby. That is much more likely in a cooperative breeding species, and much more likely when that mom doesn't have any support, because cooperative breeding species are producing babies that are too expensive for one mom to take care of on her own. Okay. So what happens is, she sort of unconsciously makes this cost benefit calculation, right? Is if she's got a baby and there's going to be help and support, good, put in the effort to raise that baby. But if she has a baby and there's no help available, what's likely to happen? If she can't feed that baby might starve, or she might die trying to feed the baby, like trying to take care of it on her own. So the calculation is cut your losses. There's no social support for this baby. Let it go. The baby was going to die anyway. Better now than later. At least you can live another day to reproduce again. Right? So you see that data in cooperative breeding species. And I can pretty much almost guarantee you that when you hear news stories of, an abandoned baby found somewhere, there's probably almost always a young female mother with no social support behind that decision, right? So that's just the downside of being a species where you give birth to super expensive babies, is if you don't have the social support, you are more likely to abandon your baby. Okay. So then I like this Hurdy article because she brings up some interesting ideas, right? And some social problems and social concerns. Oops. Okay. So what she talks about is in psychology research, she said the early psychology research on social theories and child development did not understand evolution. And that's a fair critique, right? Any of the social sciences before, or if they still don't understand evolution, they're bound to make mistakes when they're talking about humans. And what she brings up is that early psychology attachment theories only focused on the mother's commitment to the baby, okay? And it went something like this. If your mom loves you, you will grow up to be a healthy person. If your mom doesn't love you, you're going to be a mess and probably, have mental problems and end up a criminal and in jail, right? Because that's what it's all about, right? You need your mother's commitment to be raised well. Okay, but that was basically assuming you were a chimpanzee, and that without your mom, you were going to die. Okay, but turns out, hey, if you're studying Homo sapiens, right, we are a cooperative breeding species. Okay, so the research shows as long as you do have somebody there, right, an allo mother, a caretaker, right, an allo mother is anybody else who's not the biological mother to help out, can lead to healthy social development, right? So even if your mom sucks, if you have a healthy relationship with your dad, the kid can turn out fine, right? If you're raised by a loving grandmother, you can turn out fine. If you're raised by an adoptive foster family, you can turn out fine, right? Humans are more complicated, so it's not just the mother-baby bond, right? As long as that baby has, enough social support of committed adults, they'll be okay. So she brought that up. I think that's important to keep in mind. She also brings up the issue of daycares, right? And it's research here saying, trying to figure out, is daycare helpful or harmful? Is it better for a kid to be raised at home, or is it better for a kid to go to daycare? And if they go to daycare, is there any risk of that being damaging to them? So some of the research here is also interesting. Okay. So what they found is the first level is probably not surprising at all, right? If the mother or caregiver is neglectful or abusive, then daycare is probably better, right? Because it gets the kid out of abusive home and gives them at least some hours of the day for healthy social relationships. So that's great, okay? But the flip side of this is they said, okay, in those circumstances, daycare is better, but daycare can be damaging to kids, right? So it has to be the right kind of daycare. And daycare doesn't do any harm if it's a high quality daycare and the kid also has secure parental attachment. Okay. So, and at one level, this should make sense to you, right? Sending your kid all day to a low quality daycare, that might be risky for your kid, right? That could cause some problems. But, a high quality daycare with a kid who's got secure parental attachments is going to be fine. But what's the issue with high quality daycare? Okay. Any of you students out there with children, have you done any shopping around for daycare? It is rare and expensive, right? It is hard to find. Really high quality daycare is out of the reach of a lot of people, right? They have to send their kids to whatever kind of daycare they can afford, And she talks about this. There's multiple issues in here, right? His daycare workers are not usually paid well. They're poorly paid and poorly trained, especially in the lower quality daycares. There's high turnover rate in staff, right? And that does not mimic the bonding and attachments that children need to form healthy relationships, right? We've evolved to form relationships with multiple different adults, but not to constantly have somebody you form a bond with disappear, and then somebody else pops up a month later and you try to bond with them and then they disappear. This high turnover rate doesn't seem to be very healthy, right? Okay. And, you can think about why daycare workers are paid so poorly, right? Given that they're taking care of children, what could be more important than that? Shouldn't the pay be super high? But then the more you pay the workers, the more expensive the daycare is, and more out of reach it is for everybody else. So she raises some interesting thoughts here. Okay. Now, at the end of the article, she brings in sort of a big picture of human evolution here and how humans are raised, given that we're a cooperative breeding species, right? What she says is how a baby is raised is likely to have patterns and affect how a baby grows up, right? So her suggestion here is if a baby is raised in a safe and caring environment where it has secure attachments to multiple caregivers who take care of it and give it what it needs, right? Because they are connected to that baby and care for the baby, then the baby, as it grows up into a kid, into a person, should develop empathy and sympathy and bonding because it's like, oh, we all take care of each other. We bond with each other. That's how we are in my social worlds. Being empathetic and understanding and caring for others is adaptive because that's how your social world works, right? You want to learn those social skills and those social bonds so you can be a successful adult in this environment. Does that make sense? Being raised in a caring, empathetic environment would mean you would want to grow up to be caring and empathetic too. Okay, but the flip side of this is if you are raised in an environment where nobody cares for you very much, right? And everybody is selfish and looking out for themselves, then if you grow up to be a caring individual, you're a sucker and everybody's going to take advantage of you. So if your social world is selfish, that's how you should grow up to survive in a selfish social world, right? Empathy would be dangerous. So it's more adaptive, more beneficial to grow up to be selfish. So does that idea make sense? Caring environments should, it's more beneficial to be a caring individual. In a selfish environment, if you want to survive, you want to be selfish. Okay. So now, jump back in time in human evolution, right? And think about our kids, Homo sapien kids 100,000 years ago, 200,000 years ago. Okay. She says during the Pleistocene, right? What happens? What would have happened to a neglected baby 100,000 years ago, right? Who's in a hunter-gatherer foraging group, and everybody's like, fuck you, baby. Who cares? You just stay here. If you're here when we come back, then we'll give you some dinner, right? Neglected babies were probably eaten by predators, right? They would die, okay? Just like, a neglected chimp baby would die, or a bonobo baby, or a gorilla baby, right? Neglected babies die. Okay, that's standard in our evolutionary history. Okay? But what Hurdy brings up is, what's interesting is that our lives changed around 10,000 years ago when we started practicing agriculture and living in farming villages, Around that time, around 10,000 years ago, when we shifted to agriculture and village living, neglected babies probably had a higher chance of survival, right? Because the world was not quite as dangerous for them, right? There weren't lions wandering through that would just eat them, if they were neglected a bit. So she's saying that's, in one view, that's a plus side of that shift to agriculture, village life. Neglected babies no longer died. They could survive and had a chance to live. Okay. But then Hurdy raises a question. Given that, she said, well, in the past 10,000 years, the survival rate for neglected babies has gone way up. What kinds of personalities and social traits have we been selecting for the past 10,000 years? I mean, I suppose you think it's good that neglected babies don't die. I mean, it's sad, a neglected baby getting eaten. But she's like, but then if the environment can get away and the social circumstance can get away with being less caring and more neglectful and more selfish, what kind of people have we been raising for the last 10,000 years? So, if you have ever, paid attention to the news and looked out in the world and thought, man, people are shitty, she's giving you a possible evolutionary scenario for this as to why that may be. Right? So I do think that's worth thinking about, right? And also thinking about how can these problems be solved, right? How could we go about changing things to make it, more likely that more children get the full support and bonding that they need, right? In society, because it looks like that could probably improve society. But how, right? How do you make, high quality daycare more accessible to everybody? Or how do you make it so parents don't need daycare at all and can just spend time bonding and raising their own children? Think about why they don't often do that, why they need daycare in the first place, why they need social support, right? If we're a cooperative breeding species that relies on social support, to help raise healthy babies, how could we encourage that more? So I'll leave that up for you to think about. Maybe talk about it either in the article discussion board or in the lecture discussion board, but we'll see where we can discuss some of these ideas. All right, so what we've got here then, sort of to summarize what we've been talking about in lecture today. We've seen a number of birth and childhood problems and solutions, right? And biology and culture coming together here in interesting ways. right? One of the things I highlighted early on was those soft, squishy newborn baby heads, right? Why are baby heads soft? That is a biological adaptation to our bipedal pelvis that we got 6 million years ago. So it's a biological adaptation to the big brain bipedal pelvis problem. But even with that soft head, childbirth is still very difficult compared to chimpanzees. So what's our solution, Ben? Help each other during childbirth, right? And we give birth to altricial babies, right? Super needy babies that can't do anything. That is a biological adaptation to giving birth at 9 months and not being able to keep that baby in for another 3 months. So our babies are born undercooked. They can't do much versus chimps. So we have to deal with very needy, very helpless babies. Solution? Help each other out with babies. And we nurse our babies for about 3 years and have another baby every 4 years. There's biology and culture here going into the timing of nursing and how often you have babies. Each kid needs extra calories and care. And every time you add another baby on there, you need more calories and care. And that's again compared to chimps who, nurse for 4 years, have a baby every 5 years, and the baby's self-sufficient. How do we deal with these young kids? We help each other, right? We have this weird adaptation of feeding our children for many years, decades after weaning them. Again, biology and culture fit in here. So we have this biological problem of very expensive human children for a couple of decades versus chimps who don't have to do anything with their kids after age 5. Humans evolved to help each other here, right? So all of this is evidence that we are cooperative breeders, right? And who helps? Allo mothers, grandmothers who've gone through menopause, anybody else, fathers, friends, families, a whole bunch of biological and cultural adaptations about who helps raise kids. And again, this all sets up the difference with us and chimps is that chimps die in their 40s while being reproductively active. Homo sapiens evolved to live into our 70s and keep having babies. So anyone can help raise kids. That varies by culture, but it is a biological necessity that we help raise children because we are a cooperative breeding species. And that is a big part in what has made us such a relatively successful species, right? That is how we managed to get these giant brains. These giant brains don't come free and they don't come cheap, right? The only way we could evolve such a big brain is to have all these cooperative solutions in place to help raise big-brained adults that are hopefully socially functioning and good people. All right, makes sense. These are some of the unique and interesting things going on with Homo sapiens in this lecture. All right, I hope you found this lecture interesting. I think there's a lot of really cool stuff that we cover here. So that's the lecture for this week. What we're going to do next week is, now that we have anatomically modern Homo sapiens, and looked at all these biological adaptations we have, next week we're going to focus on looking at intelligence and the debates around, did we get modern intelligence at the same time that we got modern bodies? But those are the readings for next week. So I'll see you over in the discussion board this week to talk about anything you would like to discuss there. See ya.